There is something called as hierarchy key. How the key is been used, or if I ask you what is the hierarchy of symmetric key, so this should be your answer. Basically, we have protection with respect to keys. If I'm speaking about hierarchy key, first the protection comes here. So if I take this as the key, this as the key, and this as the key, basically these keys are basically protected at first. So there are, as I told, two different parts of protection. One is cryptographic protection, as well as the second part is non-cryptographic protection. Basically, with respect to cryptographic protection, what happens? Cryptographic protection is being applied whenever there is key, whenever the key is larger. If I tell a block of data is taken as one key, a cryptographic protection is applied. When I say non-cryptographic protection, whenever there is a less number of key, the key size is low, at that time this kind of protection is given, where cryptographic part is not applied on the protection part. So whenever I'm using an hierarchy key, basically it depends on how the protection is given there. If the key size is more, the protection is more with the help of cryptographic techniques. If the key size is less, I can say the key actually doesn't require any protection there, because the size is low there. So that is one part you need to remember. How the hierarchy happens is, first there is the data, then the session keys, and finally the master keys. So basically, master keys are nothing but the main keys with the help of which other cryptographic keys can be generated. Do remember, master keys are nothing but simple keys with the help of which a different keys are being generated. So whenever you get the data from the keys with the help of cryptographic protection, those are sent to the session keys. What happens in session keys are, a particular session will be there. With respect to those sessions only, that key will be working. Instead of that keys, if you are using different keys from here to here, I can say that session gets expired. What do you mean by session? Basically, in a slot of time, some task should be executed. So within that session, that key will be used with the help of cryptographic protection. Then finally, when these session keys complete its task, these are being sent to the master keys, where what happens in master keys, basically there is no much protection applied there. As you can see, the block represents a non-cryptographic protection. So this basically tells, with the help of session keys, I can generate master keys. Master keys are nothing but collection of keys. I can extract session keys from master keys as well. So this is how the use of hierarchy key happens. Or I can say, if I'm working with respect to any keys, as we all know in cryptography, one important input for any of the technique is your key. So this is the basic flow of keys. So it might fall in this category, or this category. If the key falls in master keys, you should remember I can extract both session key as well as the data. Okay, this is the simple technique. So this is actually one of the important question, how the use of key hierarchy is done for 5 to 6 marker question. So you should just represent this flow and just explain how the keys are generated, and the working of master keys. Okay, and this protection part is also important. You should know the data as well as session keys has a huge security, that is protection, but master keys doesn't has protection because it has its own authentication part. So now we'll see. Now comes the actual scenario, that is key distribution. As I told, this second part of your module basically works with respect to how the key is being distributed and managed. So we'll see how the key is being distributed. This is also one of the important part, which basically states key distribution scenario. So we all know how the key is being distributed depending on two criteria: if the key is public or if the key is private. If the key is private, only either of the, if suppose I take these two as the users, as initiator A and responder B, if I am taking private key, only this particular part, that is A should know the key either, or B should know the key. If I am taking a public key, both the users, that is initiator as well as responder, should know the key. So why basically key is used? So that you can encrypt as well as decrypt your data. So those are the basic points you should know before moving on to the key distribution scenario. Okay. So, as I told you, basically we'll study about key distribution center. If the key is private or public, that key should actually be known to the key distribution center, that is KDC. Okay, whatever the key is being used by the initiator as well as the responder should be known to the key distribution center. Okay, so these are some of the steps which are actually involved. The steps between initiator as well as key distribution center are basically called as key distribution steps, and the steps involved between initiator A as well as responder B are basically called as authentication steps. Basically, I can combine these two and tell you both are actually authentication steps. Authentication in the sense I'm working with respect to encryption as well as decryption part. So both authentication as well as key distribution scenario comes into existence. Now we'll see how the flow, how the request is being sent to the key distribution center, how the key is being sent to the initiator as well as responder. Okay. So you can see here, there is actually no direct communication between some initiators as well as responders with KDC here. You can see there is a dotted line, which basically tells you there is a communication, but virtual communication is being established. There no direct communication is being established. So from key distribution center, directly it is not communicating with both the users, that is initiator A as well as responder B at a time. But you can see there is individually it is communicating. So that is one part you should remember here. What this basically dotted line tells you, there is no direct communication between both between KDC as well as two users, but there is an indirect communication happening there. Okay, we'll see what does basically first initiator A does is it basically passes an request to the KDC. KDC in the sense, as I told, key distribution center, it basically consists of huge number of keys which is used for both encryption as well as decryption part. Now, basically, what initiator does is it sends a request by sending the IDs of both initiator A as well as initiator B and specifying the number of keys it wants. Okay, what is the first step? Initiator sends a request for the KDC with the help of IDs, both the IDs, A's ID as well as B's ID, and request the number of keys it requests. So you can see the first step, ID A, ID B, as well as the number of keys it requires. So the request is being sent now. Now, what is the second step? So you can actually link your client server model here. Now, here the client is initiator A as well as responder B. But the main client is initiator A. Who is the server? Server is your KDC, that is key distribution center. Once the client sends the request to the server, it depends on the server. If the request is proper, it will accept or reject the request. Now it will check if the request is proper, that is actual request is been sent. Once the request is received by the server, what is the next step? It should actually give you the service for the client. Now initiator has requested something with KDC. Now what is the next step? The KDC will return something, whatever the asked input, that is initiator has asked some information here. So the server, that is KDC, is passing that server. You can see it is basically encrypting the keys and sending the data to initiator A. As this data is already sent by initiator A, that is with respect to, it is asking for service with the help of some IDs and number of keys there. What basically KDC does is it will pass a key, actually it will encrypt the key itself and then pass it. Okay, because you never know, in between KDC as well as initiator A, there might be one attacker also. So this KDC encrypts the key and sends to initiator A. So what basically K tells you, K is nothing but the key, and whatever the ID is being passed from initiator A is being included in the key and sent as an a simple key to initiator A. Now initiator A has the encrypted key. So basically, initiator A will actually know how to encrypt the key is there. So that is the second step. That is, it is getting the request. Whatever the request is being sent, that service is being provided by KDC. Now, what basically initiator A has? Initiator basically has the key depending on the parameters. What are the parameters? Identification number of A, B, as well as the number of keys in the encrypted format. Okay. So once this initiator A has this key, that key is being encrypted. Basically, KDC will send the encrypted key to initiator A. Now, what is the next step? It should actually communicate the same with respect to responder B. Now comes the security part, because KDC has its security and gives a secure key, but there is no secure channel included between initiator A as well as responder B. So what does this initiator does is it basically removes all the identification number and just passes this ID, that is initiator's ID, so that it can be identified by the responder B only. That is, this key is being sent by the initiator A. So this is the third step. Encrypted key with only identification number of A is been sent now. Now once the responder B receives this data, he will think, oh, this is being sent by initiator A. Now I should perform some specific task and return it to the initiator A. So once you get the key, what happens? This is providing some input here to again initiator A. That is, one output is being given as input to initiator A. That is again the encrypted key with respect to number of keys. So once this is done, finally the function with respect to initiator A is being distributed by to the responder B. So the third, fourth, and fifth step are basically called as authentication steps, because as I told, KDC will have its own security channel, which with the help of which he can distribute anything to initiator A, but there is no security or security channel in between initiator A as well as the responder B. So the data should be encrypted and sent. Data in the sense, the key should be distributed in secure format. So this is how the game of key appears. So whenever the question is asked with respect to key distribution scenario, you should actually draw this block and you should represent how the key is been distributed from initiator A to responder B. But who is passing the key? KDC is mainly passing the key. I hope the key distribution scenario is clear to all. Hope you all are there. Students, any doubts in key distribution scenario? Just respond yes or no. Okay, we'll move further then.
Sir, fifth step, can you
Yeah.
explain it once again?
Which step?
Fifth, sir.
Fifth step. Okay. Now, I'll again repeat the steps. Okay. What is the first step? Basically, one service is being asked. Initiator A is asking for a key by sending inputs of ID A, ID B, as well as number of keys. How many number of keys it requires. What does KDC does? It will encrypt the key with the help of whatever the data you get and give it to the initiator A. What happens in the next step? This key, whatever the key you got from here, should be communicated to responder B. So what does it does? As I told, there is no security channel between initiator A as well as responder B. That encryption, whatever the key you get from KDC, is again encrypted by the initiator A and send it to responder B. So that is happening here. That is in the third step. That is the key. It should get the key from responder B. So it is represented as KB. Depending on which IDA, with respect to IDA, the key is being sent to responder B. What next? Now the key is with responder B. The responder B should work with respect to number of keys initiated in responder B. So that is happening in the fourth step. That is, that key is actually again encrypted so that it can communicate with initiator A again. Now, once the key is provided from initiator A, encryption part happens. Then for decryption part, responder B should be knowing the key, right? So it will ask again the request for initiator A that send a key because I want to decrypt the data. Encryption is being done, decryption should be done. So to decrypt the data, this request is being passed with respect to number of keys as well as the key from responder B. So that is one thing. Then once the request is being received at initiator A, what initiator A does, it will check, responder B needs the key to decrypt the data, and finally again sends the final encrypted key to the responder B. You can see here in the fifth step, I'm using something called as f of en2. So whatever the request is being sent, the same request is being sent as a function here. So what is the usage of function is in this step? Basically, the key sent from responder B, that is the request of key sent from responder B, is bit secure, but initiator A is securing that particular key in more what I can say in higher level. What this function represents is, as we know, the key should be specified. The length of the key, size of the key should be specified. With the help of this function, the size of the key will be reduced or increased based on the responder request. So you can see encrypted key is being sent with the number of keys here with the help of a function. So these three steps are taken as an authentication steps. These first three steps are actually taken as key distribution step. So one common step between all the processes, the third step, which is actually a key distribution step as well as an authentication step. Hope the doubt is clear.
Yes, sir.
Yeah. Okay. We'll move for the next part. That is hierarchical key control. In the previous slide, you can see I told you how the hierarchy of the key works. So we'll see how the controlling of such kind of keys happens there. This is actually another part. This is actually not linked with respect to your key distribution scenario. It is actually another part. This comes under your managing your keys. Okay. So we'll see how the hierarchy of the key is being controlled here. For communication among entities within the same local domain, the local KDC is responsible for key distribution. As we all know, with respect to key distribution centers, whatever the functionality happens there, it is all dependent on the KDC, that is your key distribution center. What does this particular statement tells you? Whatever the working happens from the initiator A as well as responder B, in between KDC is responsible. You can see here, if something happens in the part of initiator A, who will be responsible? The initiator A cannot blame responder B for any wrong thing happening there. It can blame only KDC because whatever the key generates, whatever the service provided by KDC only will be taken as an input for initiator A. So that is the point telling there. Whatever the local activities happens in the channel or in the process, only KDC is responsible there. Then, if two entities in different domains desire a shared key, then the corresponding local KDCs can communicate through a global KDC. That this statement is an important statement. You should remember, if two users, if suppose user A as well as user B wants the same key in the sense, if I can tell, if they want the same key to be used, they can declare it as a shared key. So while the declaration of shared key, what happens, the KDC cannot actually initiate that process. At that time, basically, this key distribution centers communicate to global KDC. Global KDC is nothing but there are different channels in KDC also, key distribution centers. Basically, we will be working with respect to local key distribution centers. There will be something called as global key distribution centers. Global in the sense who will be managing the local key distribution centers. So at that time, KDC will actually have no idea what to do. So local KDC will access or request for the help from global KDCs. So that is one part you should remember. Then the hierarchical concept can be extended to three or more layers. So whenever you want to implement the hierarchy key, that is a key hierarchy to you can use many kinds of layers. It is not limited there. So what happens in layers? Layers is basically huge number of data or keys can be generated there and used simultaneously. Then, if I am using hierarchical key control, this type of scheme minimizes the effort involved in master key distribution because most master keys are those shared by a local KDC with its local entities. As I told, with respect to key distribution, what we basically do, we'll be working with local entities. So, what is the usage of hierarchical key control is? It basically minimizes the task there. What kind of task? So that the master key is not being distributed for both sender as well as receiver. So this hierarchical key control basically generates its own keys which can be sent as an master key. So that is one of the advantage of using hierarchical key control. It limits the range of a faulty or subverted KDC to its local area only. Now, I will take one simple example, real-time example here. If something happens in your class, what you basically do, you will inform your class teacher or you will inform any of the subject handling faculty. So those faculty will inform if the matter is very serious, it will be taken to the HOD. Okay, so that is the process we basically follow with respect to college. You can apply the same concept here. That is, if there is any fault inside a local KDC, it is actually solved there only. It is not taken up to the higher authority. You can see it is solved in the local area only. That is, the range of faulty or subverted KDC is set to the local area only. That is, within that local part only the problem has been solved. It is actually not taken to the higher level. Higher level is nothing but in this key distribution center, global KDC is actually your higher level part. So this is how the hierarchical control works here. So depending on what kind of KDC you are using, if it is a local or global part, it depends how the communication happens between local as well as